number 45, it says draw the resultant wave for the two waves shown in figure A and the one for figure B. Now in figure A, you can see that these two waves are in phase, and I say that because I have a crest and crest lined up and a trough and trough lined up. And so the resultant wave is going to be, if I think about drawing in the equilibrium line and looking at the amplitudes, the resultant wave is going to be 2 times as big on the amplitude, and so 1 time, 2 time, and 2 times as big on the amplitude right there, and 2 times as big on the amplitude here, and 2 times as big on the amplitude there. And so it's going to be something like this. Okay. Over here on the figure B, I've got troughs and crests lined up and crests and troughs lined up. And so you can see that every time I would have a positive amplitude, I'm going to have the corresponding negative amplitude to add to it. Even if it's a spot that's not the full amplitude, but it's still going to be correspondingly negative and positive. And so that wave is going to add up to nothing. So this is an example of total destructive interference in B, and in A, constructive interference. In 46, it says two wave pulses on a string approach each other at the time t equals 0. Each pulse moves with a speed of 1 meter per second. Make a careful sketch of the resultant waves at 1, 2, 2.5, 3, and 4 seconds. So the waves are going to continue to move forward. And so in 1 second, this wave pulse is going to be here. In another second, it's going to be here. In 2.5 seconds, it's going to be sort of halfway in between 3 seconds and 4 seconds. And you get the idea. And pulse 2 is going to do the same kind of thing. And so if we would go ahead and draw 1 second from now, wave 1 will be here, and wave 2 will be here. In a second from that, wave 1 will be here, and wave 2 will be here. So this is at time equals 1 second. This is at time equals 2 seconds. What about 2.5? At 2.5, we're going to be moved half a box forward. And so it's going to be there. And they're going to overlap on each other perfectly because the other one's going to move half a box forward as well. So it's going to be like this. What kind of interference do you see there? That's right, constructive. Now, in 3 seconds, they're going to be another half a box forward, and so it's actually going to look a lot like that one at 2 seconds did, except the waves will be in different positions. Three seconds, and then at 4 seconds, the wave that started on the far right is going to be right there, and the wave that started on the far left is going to be right there, and that's going to be 4 seconds. On 93, they say which one of the waves is the resultant of the other two. That is, which one of the waves is the interference pattern of the other two. Well, if you just kind of guess and check on this, if it were the green and the blue added together, the interference pattern of that would be humongous. Say right here, the green amplitude is this, the blue amplitude is this. That would mean the red one would have to be as big as both of those combined, and it's just not. And so what about maybe green plus red equals blue? How would that work? Well, let's try right here. There's red. There's green. Yeah, that looks pretty good right there. But let's try here. There's green and there's red and there's green, and green's a little bit bigger, and yeah, look, that works well. Oh, and here you can really see it. because red doesn't have any amplitude and green doesn't have any amplitude, and so blue doesn't have any amplitude. And so it looks like it's the green plus the red is equal to the blue. On number 94, they say sketch the resultant wave that's produced by the two waves. Well, you can see that we have a +1 and a +2, and then a -1 and a -2, and they are lined up so that at this 1 to 2 spot, we're going to have total destructive interference. And over here, we're going to have some destructive interference, but not total. So you can see that we're never really going to need to go into the negatives. So I'm just going to draw along here like this. There's nothing, nothing, nothing. Even especially here, I had a +1 and a -1 that gave me nothing. And then I come over here, and then I have a -1 and a +2. And so that's going to give me just a +1 for that point. And there was nothing here to add on to this +2. And so that's going to go up to the +2, and it's going to look like that. On number 99, it says two wave pulses on the same string approach one another at the time equals 0, as they show in the picture. Each pulse moves with a speed of 1 meter per second. Make a sketch of the resultant waves at 1, 2, 2.5, 3, and 4. Now this is similar to what we had the last time, except do you see how pulse 1 is twice as tall as pulse 2, but pulse 2 is twice as long. So pulse 1 is going to move forward 1 block in 1 second, and so is pulse 2. Now pulse 2 is from 5 to 7. It's going to be from 4 to 6, and I'm only drawing it half as tall. So there's 1 second. At 2 seconds, they're both going to be moved forward 1 block. And now you can see they're going to start overlapping because pulse 1 would be in here, and it would be 1 block tall. And pulse 2 would be half a block tall there and there. And so we're going to have an interference pattern that's going to be 1.5 blocks and 1 block, something like that. That's at 2 seconds. Now I'll take 2.5 seconds. And so the pulse 1 is going to be moved half a block forward, and so it's going to be in here like this. Pulse 2 is going to be half a block forward, and so it's going to be there, there, and there. And so this is going to be kind of a neat pattern. There you go, 2.5 seconds. Now, it might be easiest to look up at 2 seconds and go to 3 seconds, because now they're both going to be moved forward. And so pulse 1 is going to be 1 block tall, and it's going to be in here. And pulse 2 is going to be half of a block tall, and it's going to be here and there. And so our interference pattern looks like it did before, but kind of the mirror image of what it looked like at 2 seconds. So that's 3 seconds. And then lastly, at 4 seconds, pulse 2 now is going to be here, and pulse 1 is going to be over here. And so we're going to see that they have switched sides like this. So now in number 100, we're going to do that same thing again, but this time we're going to say that the pulse 2 is going to be down instead of up, like that. And so not this one, but down. Okay. So Similar kind of thing. Pulse 1 in 1 second will have moved to there, and pulse 2 in 1 second will be, its lead edge will be at 4, and so it will be down here half a block tall. So there's 1 second. At 2 seconds, they will be overlapping in this center spot. Wave pulse 1 would want us to go up. Wave pulse 2 would want us to go down. And so we're going to end up adding those two together. And we're going to have that 2 seconds. Now, how about 2.5 seconds? We're going to have wave pulse 1 that's going to be halfway across the line like this. And wave pulse 2 will be halfway across the line like that. And so it's going to be down for a little and then up for a little like that. 2.5 seconds. Now, how about 3? Again, like I said on the last one, I think maybe it's easiest to go from 2 to 3 and maybe skipping over the 2.5. So you can see that the front edge of pulse 1 is there, and it's going to move 1 forward. And so pulse 1 is going to be there, and the front edge of pulse 2 was here, and it's going to be moved 1 over forward. And so we have something like this. And so there's my 3 seconds. And 4 seconds ought to be even easier. With 4 seconds, the wave pulse 2 now will be 1 block forward still. And wave pulse 1 will be 1 block forward still. 4 seconds. Two waves that are superimposed one on top of the other, and we have plenty of spots, and we're supposed to decide whether constructive or destructive interference happens. Well, this is an easy one, because if it's a place where the two amplitudes have the same sign, that is, the two waves are displacing the medium in the same direction, then we have constructive interference. And if they're going in opposite directions, destructive interference. So at G, I can see two positives, so that's constructive. At H, I can see a positive and a negative, so that's destructive. At I can see a positive and a negative, so that's destructive. At J, I have a negative and a negative. A lot of people get this one wrong, but this one's constructive. They're moving the medium in the same direction. At K, I have positive and negative, destructive. At L, I have positive and negative, destructive. At M, I have negative and negative, that's constructive. At N, I have positive and positive, that's constructive. And at O, I have positive and negative, that's destructive. And this is a really neat premise here. Two water bugs are creating waves, and so these waves are going out in a two-dimensional pattern rather than just a one-dimensional thing like we've seen on the other ones. And so as it says, the thick lines in the diagram represent crests and the thin lines are troughs. It says several positions are shown to determine whether they're constructive or destructive interference. Well, at spot A, we have two thick lines crossing, and so it's crest on crest, so that's constructive. At B, same kind of thing, two thick lines, so a crest on a crest make constructive. At C, though, we have a thick line and a thin line, so destructive. Kind of a funny way to write that. At D and at E and at F, we have all destructive interference because you can see it's a thick line, a crest, and a thin line, a trough. So we'll say D and E and F, those are all destructive.